Hello, everybody, and welcome to the show. It's Between Two Servers. I'm Glenn, and with us today is Jay Mattis from High Horse Entertainment, one of the co-founders there. They've created a cool library for game developers called Snapnet, and they recently released, is it recent?
2017, 2018, so not that recent.
It's pre-pandemic.
Yeah, right. So it's
a long time ago.
Yeah.
A long time ago, Jay released a game called Disc Jam, and in a past life, Jay worked on Call of Duty at Activision, doing a bunch of Netcode. Welcome to the show, Jay.
Thank you. Thanks for having me.
Cool. So this may be a very long episode. I recommend everybody go out and get a cup of coffee right now, make some tea, sit down. We could be here all freaking day because we have a lot to talk about. Because Jay and I have basically the same pedigree of Netcode. And I would also say, like John Shiring, a really good friend of mine at Respawn, with the common code base and ideas and shared history between myself, John Shiring, and Jay, we've effectively been working on the code base for the last decade or so, the same code base or different variants of it. And I know we agree on a lot of things related to Netcode, because when you look at games like Call of Duty, Titanfall, and Apex Legends, I put it to you, this is Netcode done right. Okay?
Great.
So this is something that you really can only know when you have the background that Jay, myself, and John Shiring have. But this is really a best of breed solution. So we're going to talk a lot today about the best breed networking, and Jay's going to talk about a whole bunch of stuff, really interesting stuff. So before we go there, let's dive in a little bit on your background, Jay.
Sure.
So when did you decide to get into games, and how did it happen?
So I had never really intended to get into games, actually. I was always interested in programming since I was very young.
When did you first write? When did you first code?
I was, what happened actually was we had this old kind of IBM compatible PC with two dual 5.25-inch floppies. Lived in a small town, and there were a couple games that were at our local shop, like Sesame Street, Winnie the Pooh, young kids games.
Yeah.
But I was like so fascinated. And so I was always wanting more games, and it's like, that's all that was around at the time, and there was the conversation that my dad had with me where he was like, this is really mainly a business tool. Most people are writing their own software for the few things that they need, and there just aren't that many games. And the idea that someone was behind this kind of stuff, that there was a human on the other end generating that, was obviously not something I thought about. No, that blew my mind, and I was like, I want to know how that works. And of course I was really very young at the time, but my mom, my champion, was at a bookstore and found a book about BASIC, which BASIC A came on the DOS diskette at that time. And my dad, as the kind of sense of humor that he has, took the BASIC A reference manual that came with the computer at the time and gave it to me and said, go ahead.
Wow.
And so that was obviously not something I could wrap my head around. But my mom brought home this book that was like, it was called I think the Absolute Beginner's Guide to writing games in BASIC or something, and it had crucially games there in print. And I would sit on her lap typing them in, and it would be like a letter guessing game, literally I'm thinking of a letter, what letter, it would tell you how many tries. And I learned a lot from the trial and error of, not having typed things in correctly, having to learn what these different error messages went, that whole value of perseverance of I need to play this game. I know that it's possible. I know that it works. I just need to figure out what I messed up. And then, tweaking it here and there and changing messages. And, so it just snowballed. I mean, it was very early, and I was super into it.
We have almost identical backgrounds. I learned programming from the reference manual that came with my dad's IBM PC AT286. Yeah. and I was 10.
Yeah.
And obviously I sucked.
Yeah, exactly.
Very long time.
I sucked for a very long time. Yeah.
Yeah.
And I was very lucky that actually when I was in middle school, I met a friend who had done a lot of this as well, but he had actually learned C and C++.
Okay,
and
so you went
that was a huge moment for me in terms of like my jump in learning, because I had tried several times and couldn't quite wrap my head around some of the concepts, and so together we kind of overcame a lot of that, and it was really quite helpful.
That's awesome.
So yeah,
really
so
awesome.
that was never the intention, but my point though is actually that, I think for anyone who gets into this stuff, what are you going to program? You're not going to make Excel. That's not fun, right? You're going to make games. Like, what else are you going to do? You're going to make little things that are kind of fun, that amuse you. And so, I was very into video games, especially because, it's just a great time to grow up. The technology, the way that it was evolving, every single new generation of games were more exciting than the last, doing really kind of novel, interesting things that you didn't even think was possible the year before, so I was hooked to that aspect of it. So I'd always been into that, always been doing that, and tinkering. And then in college, it was my sophomore year, and
so you were in Rhode Island at that point?
Yes. Yeah. So I was in Rhode Island. I was studying computer science, which had always been the obvious track.
Now, unlike me, you didn't drop out, so kudos to you.
I did not. Though when I interned at Activision, that was offered to me, and it was very tempting.
Yeah.
It was very tempting. And
so you interned while you were doing your computer science degree?
Yes. So what happened was, it was sophomore year of college, and I was on the phone with my dad, and it was early in the year. It was the fall, and he said, I just want to get this in your head now, that if you think you're going to just come home and bum around all summer and not do anything, like, that's not really a thing. Like, you should get a job. And like, I just think it's early enough that I should probably have this conversation with you now. You have plenty of time to think about it. And so I said,
I dropped out of college and bummed around at my parents' house for 2 years. Thanks, Jay.
So yeah,
my dad didn't warn me ahead of time.
Yeah. So I had that warning.
Maybe you should have.
And I said, "Ooh, I hear you. Okay." And that kind of threw me for a loop. I really wasn't expecting that. But it was early in the year, and also because it was my sophomore year, I was like, I was planning to do like biomedical stuff. That was like what I was thought I was going to do. But I was like, it's probably a little early to do an internship.
What year was this?
What calendar year? 08.
Oh, 08. Okay.
Or maybe no, this was I think it was 08 or 07.
Cool.
And I was like, it's probably a little early because it's my sophomore year to worry about getting an internship that's going to turn into a full-time gig. I should just do something that's like going to be different and fun. And so I applied to kind of the usual suspects that CS guys were applying to, the big Facebook, Apple, whatever. I also looked up all the game studios and look at hey, are there any game internships? That would be super cool.
So just from your own interest, you were just like, I just think this would be cool because I love games, and why not? And
I just thought it'd be super fun and a great experience, and I couldn't think of anything else I could do for a summer job that I thought would be more fun than that. So that was like, well, let's see what happens. I didn't really expect much of it, but I sent my resume out, and luckily, what happened actually was that I have, everyone's like, oh, you gotta get your resume should be one page, whatever. But I had all these little side projects that I'd done over the years, and I thought that it was like super relevant to, because like, what else have you done? My education experience isn't that interesting. I've been in college for 2 years. Like,
anyone watching this show, the number one thing that will tilt it in your favor, applying for a game industry job, and from my experience on both programming and design, are examples of work that you did in your spare time because you're just passionate about this and this is what you want to do, right? What little projects have you done, right? Because you didn't even know this at the time, did you, Jay?
I did not know that. I did not know that at the time. And what I especially didn't know was that a few years prior, when I was still in high school, I don't know if you remember these devices back in the day, but they were these pocket PCs.
You mean like the
ran
Palm
Windows
Pilot?
CE.
All that?
Yeah,
Oh,
but they ran
the
Windows
Wince
CE.
ones.
Yeah. So there was like, and there were like 3 versions. One was like, compacted these ARM devices. There was a MIPS one and SH3. Anyway, so I was always super into like portable computing and this kind of stuff. It was like, this is the future. This is what we're doing. And so I had one of these things, but it was like the cheapest, lowest end one. So there was the Pocket Quake project to get Quake, take the source code and get it running on these Pocket PCs.
Yeah.
And I so wanted to see what that was like, but it didn't run on my processor because it was too crappy for anyone to care about, because it was going to run like garbage. And normally you could take this solution, you compile it for the new processor, and it would work. But it didn't work because there was actually one of the core drawing routines was an assembly.
Oh, so inline assembly or whatever.
But it was actually was being optimized incorrectly by the compiler. Is what ended up happening. And so I was like, I had realized that it would run in the debug configuration, but it wouldn't run in release, and I couldn't figure out what was going on. So I've got these pragmas everywhere, and I'm trying to like binary search the code base down to figure out what. So I figured it out, got it. So now I had this thing running. And so I had a small credit on that project for having figured that out. And so I had listed that I had done that. And of course, what I did not know at the time, which of course is that Call of Duty is built on the Quake 3 engine. And so, so that was a big deal. So they saw that and they were like, oh, like this is amazing. An intern that knows anything about the Quake engine, who would expect, right? And so I was planning to be interviewed at Microsoft at the time up in Seattle. And so it wasn't typical for Activision to, fly someone across the country or something to interview for an internship. But I was like, look, I'm already going to be on the West Coast. So it's like, what if you just flew me down and back? And they said, okay. Cool. And so I got them to do that, and it was awesome. It was a great experience.
So you would have done an interview there and a whiteboard and some stuff, and So it's a tough experience, It's something that.
And I remember I had lied at the time, and they're like, "Oh yeah, I love Call of Duty," and I hadn't actually played it before. And so they handed the controller to me, and the first thing I did was threw a grenade and blew myself up. And I was like, "Oh, that's so bad," because I was trying to desperately quick figure out what all the buttons were, and I was like, "That's not a good showing." So that was my one, I think, faux pas in that interview. That was not great.
I love this game.
I was like, "Oh yeah, I love Call of Duty, play it all the time." No, I hadn't yet.
Rule number 1. Play the fucking game. Before you interview with the company. Rule number 1. But
absolutely.
Some programmers can get away without it, but you're gonna have to have a good bloody reason. Yeah.
And what blew my mind actually at the time was, when I agreed to do the internship, and I was told, that I was going to be working on Call of Duty. At the time, this is right before Call of Duty 4 came out, and so I had all these magazines that had Modern Warfare on the cover. They had just done their E3. It was like huge, right?
Yeah.
And
it was a massive time. Like Modern Warfare just blew everything up. 2008.
Total game changer. And so no one had really played it yet, but it was hyped.
I was at the E3 competing against Modern Warfare, and we got rolled. Like this shit looked amazing.
It was amazing. I mean, it was just amazing.
And at 60 FPS.
Yep.
Amazing.
Yep.
Amazing.
Yep.
Yeah.
And so I was all excited. I'm going to work on Call of Duty 4. This is amazing. I'm like, no. You're going to be working on Call of Duty 5. And so then that blew my mind, because I didn't understand that they were doing this annualized thing, and they were leapfrogging studios over each other, and each studio was taking 2 years. So that was also a huge change in my mindset about how game production, game development works, right? And so
just for everyone on the call, it's a Treyarch, and it's the Infinity Ward leapfrogging every other year.
Yes.
Yeah. Okay.
Yes.
Cool.
And I think what had actually happened up until that point was they decided for Call of Duty 3, I believe, that they wanted to do it annual. And it was like, hey, what studio can make a Call of Duty game in a year? And Treyarch was like, we'll try. That's my understanding of how that went down. I wasn't there for that.
Pain.
Yeah. but it put them obviously in a great position to do
great studio
franchise. And so they had done that, but then obviously Call of Duty 4 was so massive that we were trying to take drops of that game as they were making it. And so it was just an awesome experience, right? Because as an intern, you get to go in there, and a lot of the guys who were at Treyarch at the time, they had a lot more experience in that type of engine than I did. Obviously, they're just unbelievable engineers at Treyarch. But
very, very high quality bar. Treyarch, Infinity
extremely, which I didn't truly appreciate until I left, because that was
top tier talent here. Yeah.
But they're taking drops with this new thing, and we all get to figure it out at the same time, right? And so that was also really fun as an intern. It was an amazing experience.
That's amazing. So look, Jay, you got to work on some of the best netcode in the industry. Perhaps what I would consider to be the best lineage of netcode, the Quake lineage through to Counter-Strike, through to Call of Duty, and then on to Apex Legends, and then other variants. And it's not just netcode; it's a way of life, right?
Yes.
So let's dive in on let's do a rapid fire section.
Okay.
And we're just gonna. It's sort of like I'm just going to ask a question, and let's just get your quickest, hottest take, okay? And then we'll move on. And we'll do this, and we'll dive in details in the section after this. So a bit of gimme for the first one: UDP versus TCP.
UDP.
Okay. Why?
Why? Okay. A lot of reasons. Head of line blocking is really the major one. You can't, even if you have a game in which you need, reliable data, like let's say you're just sending inputs. You don't want to have to wait for the retransmission of a packet that gets dropped when you could send all of the inputs in the latest packet. So UDP is even superior for things like that.
Amen. Okay. Quake style versus Unreal style.
Quake style, for sure.
Okay. Why? What's the difference and why?
So, my major. So there's a lot of differences. The biggest difference, of course, is in the Quake style of networking with snapshots. You get full state updates of the entire world at once, and critically, that update is timestamped, right? So you have everything about the world, and when it's timestamped. The Unreal networking, on the other hand, you will get some updates for some objects. They won't necessarily be timestamped, so you don't know exactly how old they are. The kind of tricky bit really with games is that games are about objects interacting, right? Like they're not about objects in isolation. And so when something happens in the game, you're changing state on multiple objects at the same time. This impacted this touched this shot this. So to not have any guarantees about what order you're getting those things and whether you're getting them at the same time, and then furthermore, how old that data is, I think it's very difficult to compensate for that appropriately.
Bingo.
You got to kind of do it per mechanic. Whereas the thing about Quake is that the networking just works, and then you build your gameplay on top. You don't think about it.
Yeah. I've got to agree with that. And this dives into the whole snapshot discussion. We'll talk a lot more about snapshots later. Interpolation versus extrapolation.
Depends. It depends on the what exactly you're trying to get done in the game or the mechanic. Generally speaking, if you can, interpolation. But sometimes, like a good example is there's a reason that all kind of melee attacks in shooters feel like shotgun blasts, right? You can't really
they're literally implemented as invisible shotgun blasts.
Right. You can't really touch, push, pull the other guy, change his state directly. And so if you need to do that, then sometimes you got to extrapolate.
Got it. Okay.
Or with sports, that could be another reason.
Good point. Okay. Determinism or sending state?
Sending state, I think, is almost always ideal. The challenges with not sending state, aside from the fact that you have to make it deterministic, which can be a challenge in itself, especially in the new world order of cross-platform everything.
Yeah.
You know, you've got to deal with late joins and how you deal with stuff like that. You've got to deal with the spiral of death of what happens if you can't run enough
simulation
frames to catch
bound.
up.
Yep.
You know, so these things are all kind of go away if you just send some state.
Yep. Good point. Client server versus peer-to-peer.
Client server for sure.
Why? Why?
Well, you know, here's one of the things about peer-to-peer, right? Even in fighting games, and I love this argument, right? Fighting game guys are really big on the fact that their games have to be peer-to-peer because they want to be directly connected to that guy, right? So they imagine you've got point A, that's me. You got point B, that's the other guy. Adding a server in the middle has to make that worse, right? But no.
But it's just not how it is. Yeah.
Right. Glenn is the expert of this at the moment, right?
Yeah.
Like, you know, there's actually, it's not true that the shortest point is
the internet is not a series of tubes, everybody.
No. And the internet is not optimized for my house connecting to your house. It is optimized in a lot of ways for me getting to Amazon. It is optimized in a lot of ways for me getting to Google's cloud, right?
It's actually optimized. If it's optimized for anything, it's optimized for cost.
Yeah.
But you could kind of look at it as being, it's optimized to get you to the nearest internet exchange point. Maybe.
Right.
That's maybe one way to look at it. And I'll bet if you're in Santa Monica and you're playing against someone, you might be going down to one Wilshire in downtown LA and then back to the other dude's house.
Yep.
It's just how it is.
Yeah.
Okay.
Yeah. And so if you could have your server closest to there, it might not be any worse. It might even be better in a lot.
Yeah, I've actually seen it.
So
I've seen it better. My worst experience shipping a game was a peer-to-peer game.
Yeah.
And the inconsistency of peer-to-peer is just tragic.
Yeah.
Okay.
Yeah. So there you go.
So another one, player hosting versus dedicated hosted servers.
Dedicated for sure.
Why?
Multiple reasons. One is that upload bandwidth is not great still in a lot of places. You know, when you look at a lot of common home internet connections, download speeds can be extremely high. Like here, I have 300 megabits down and I have like 20 up, right? So it's really optimized for download. And so when you become the server and, you know, depending on the player count of your game, the bandwidth usage, right, you have to send everyone's data to them. And you can really be the bottleneck. And on top of that, it can be really challenging actually to measure that appropriately in your title. And so knowing whether or not someone's a good server can actually be quite a challenge to get right. And then on top of that, you have the reliability.
It may not even be a constant thing. They might be on Wi-Fi and just cook
right. And also this is a problem with matchmaking too, right? This is why matchmaking is such a headache. How do you deal with the conflicting issues of bandwidth, upload bandwidth on one side, but latency on the other? Do you go with the guy who, you know,
NAT type,
right?
Maybe they're
connectivity. Can everyone connect to them? Does it have to go through a relay? You know, these are things that are not. There's no right answer.
Host migration.
Yes, and then finally host migration, which you don't want to have to write first of all, but no one even wants to sit through. Even if you do get it right, it still sucks. The experience is not good. And realistically speaking, if you can't afford your servers for your game, you're not really monetizing it very well, right? I mean, like practically speaking, what these server costs, you know, if your game is optimized as well as it can be for fitting as many things on a server as you can, even if your game's free, you know, you should be able to make that work. You know, the one case where it's really a negative is when your game is like on life support and you really want to keep it available for people to play.
There's a minimum
spend. To a minimum.
Yeah.
So there's a minimum spend. Yeah. That's the one negative, but you know, you can't choose all of your game development based on having to keep your game on life support. That's not the path to success, right?
Yeah. Plan for success. Okay. How about last question? Cloud versus bare metal?
You know, I don't have a strong opinion on this because I don't have a lot of experience. We go cloud because we're a small group and I can't be managing bare metal. But I have not worked, for example, with Multiplay, who does bare metal. And so I'm actually not very aware of the pros and cons of that.
Cool.
But I would love to know your take.
My take is a mix is good, and I see surprisingly good performance on cloud these days. The only thing with cloud that kind of gets me is that high egress bandwidth charge is a bit of a kicker. And if that high egress went down, the flexibility of cloud would just
that's
win
interesting.
every time.
Egress has not been very expensive for us overall. I mean, maybe our game is just such that the bandwidth just wasn't very high.
Oh yeah, man! We have some customers who do megabits, and it's just like holy, it's like half of the server cost.
Yeah, that makes sense.
So it very much depends on how much bandwidth you're using. I would love to see the price go down, and typically with bare metal, you get a certain amount of bandwidth kind of baked into the price. But of course, you can't just spin it up and shut it down on a minute basis. So
right.
Cool. Okay, let's dive in now. So let's talk a little bit about SnapNet. So you've worked on, and this is a product that you guys have created. I'll just throw up a little screen share here and show you the main website. So we got here SnapNet, AAA netcode for real-time multiplayer games.
Yeah.
Tell me about it. What's the deal?
So the deal is a couple of things. So obviously I have the experience with Call of Duty, and then we also have done a sports game that was, it's sort of like Pong with people. Sort of, you throw a frisbee and you're kind of playing air hockey with it. Very fast game. The type of thing you would probably use rollback or something like that for. We at the time had been developing the kind of Quake style netcode within Unreal Engine, and we used that with some tricks to make that not so bad to ship.
But you were just missing your Quake style netcode inside Unreal. Is that the Genesis?
Sorry, wait.
Is this the genesis of Snapnet?
Basically. Yes.
I don't want to use Unreal netcode anymore.
Oh, yes. The genesis was definitely, I want the experience that we have had at Activision working on the Quake engine. Definitely exactly what you said, right? Of like the epiphany and I tried to do multiplayer stuff before working in Treyarch, right? And I'm embarrassed, frankly, about what
once you see how it's done.
But once you see how it's done, there's no going back. I mean, it's obviously superior. It's obviously the right approach in terms of you can't have your gameplay engineers focused on the networking of the mechanic, right?
Yeah.
You want them to know that if they do it within the framework, that it's just gonna work and be correct, right? And because these things are insanely difficult to test. I mean, even with us making that Disc Jam game, it's a 4-player game. There's 2 of us, right? We need that stuff to work right away and work the first time, and not have to worry about testing every network condition for every mechanic, right? It's just you can't even do it, right? It's just such a recipe for disaster. So a lot of it came down to we want to do this. Which we did, and we did it in certain ways that were, had some success, learned some failures about, we were working with Unreal for the first time about the best way to kind of integrate some of this stuff. As well as, obviously writing that model from the ground up, learned a lot doing that. And then on top of that, we then were doing this game that really wasn't a great fit for that model because it's a sports game.
Thinking about a sports game using a Quake model, the first thing I think of is, look, here is a model fundamentally designed for multiple players to move around a mostly static world and shoot at each other, ideally with instant hit weapons, thinking more Counter-Strike, Call of Duty here. But only to interact at a distance, to the point where you could not even allow the players to. Some games even don't allow players to collide, because there's just no way to make it good. So how did you solve? I prefer that too.
I prefer that. So what we did was we actually have for every player, they actually have their own copy of the disc that is predicted along with their player. And then we only ever show you the disc for the local player. So everyone's showing the predicted disc. That has the negative, of course, of you can't predict the catches. We could have blended between.
I think Rocket League does something similar with the ball. They're doing the Quake prediction on the ball.
Well, but they do it for everyone. And that was actually, it was essentially the same kind of idea that I was having, is once you go down that route and you realize what you're doing, which is to say, like, look, I really need to be able to predict those catches, right? And there's really no reason I can't. It's kind of stupid that I can't, but I can't touch his state. And so you quickly get to the same kind of model that the fighting game guys have, right? Which is like, I want to just simulate this whole thing forward.
So
the game's not that big.
You're talking now about a GGPO style.
Yes, and where you say, I'm going to simulate the whole game forward, not just myself, myself and the disk, but really I want to simulate them too and do everything they're doing. And I want to simulate the game forward because then I can touch their state. I can predict the cache, right? But traditionally, that requires.
I'm going to throw up a screen now with GGPO, and this actually is an open source project.
Yes.
And best of breed, best of class for the low player count fighting games that are deterministic. Fair to say, Jay?
Yeah, absolutely.
Cool. Okay.
It's certainly a benchmark of.
So this is ggpo.net. Okay.
And so with GGPO and the like, right, you're sending inputs only and your whole thing's deterministic. And that just doesn't jive with what we're trying to do, which is really full 3D titles in Unreal Engine. That's cross-play and cross-platform.
You don't have this deterministic core built into Unreal Engine. So one way to go would be to go, I'm going to make my own deterministic game engine core, and for my netcode and everything in its
your own collision, your own math. You're going to use fixed point libraries or
heavy lift
software point. It has performance impacts. It has workflow impacts. And it's, you lose a lot of the benefits of working with something like Unreal Engine, which has a lot of workflow stuff built into it, right? You want to be able to make use of their tremendous library of utility functions, everything they're doing, and being able to pull data, even just pulling data out of like something that you configure, right? Can you guarantee that when you cook it, that floating point data is the same? I don't know. Do you want to go down that road? Right. There's a lot. Do you want to be the person who binary search debugs that on a right? Or you're trying to playback in the debugger? Trying to play back some animation, right? And you need to get some bone location. How do you get it deterministically, right? So once you start getting into the full 3D, there's a lot of challenges there to doing that. And that sort of led us because of the floating point and all that sort of stuff. Yeah, and you have to use, if you're doing crossplay, you have to be using multiple compilers, depending on the platform. And so getting these things to all sync up is like, an exercise in frustration. And I whether or not it's even really doable without having to heavily modify Unreal Engine.
I would say, generally speaking, like if you're going to have the same freaking compiler, right, and then do a bunch on every platform, and then also, right, and then also do all the stuff again. It's doable, but you have different compilers and different runtimes on different platforms. No way in hell. Not going to happen. Cool. And so then this kind of led us to the idea of, well, look, like what if we take the kind of same Quake stuff that we're doing, right? But you can maybe you're only predicting your local player, but maybe you can also run it in a mode where you're predicting everything, right? So now it doesn't have to be deterministic as much as you've realized something that I think I've also realized myself in the last 10 years, which is honestly, it isn't necessarily as black and white as GGPO style or Quake style. Yes, there is a definite cutoff on is it 100% deterministic or not, right? But in terms of how you're networking it, in terms of rollback and prediction, there really is a continuum between how much am I simulating everything or just the player. Yeah, exactly. And, you could simulate, if you simulate everything, but you're still sending state, is that equivalent to GGPO rollback? I would say that it is, right? And same thing with, with the fact that a lot of like GGPO, for example, in a lot of games, they'll set a constant input delay, so that input delay because of the rollback. But that's also something that you can be flexible with, right? Like you could do full input delay, and then it's basically synchronous, right? You're not doing any prediction. You're kind of this is like kind of there's another continuum model. Right there. But you're doing now, so now it's like, oh, you're doing lockstep, quote unquote, but you're still sending state and it's not deterministic, right? Or you're doing full prediction, or you could do anywhere in between, or you can adjust it on the fly. It depends what you're rendering versus what you're sending, right? So the kind of the realization that you were saying, this is not black and white, there's a spectrum, and that actually there's a way that all these things can live under the same umbrella without it being a nightmare, right? That's effectively what you do with SnapNet. Yes, exactly. And so with SnapNet, you can control,
are you doing local player prediction only, or is it entire simulation? That's one toggle. Then you can also change up, for example, you could say, oh, when you can control essentially how you want it to compensate for latency. So you could say, well, if you're doing a shooter model, you could say, I don't want input delay ever. I never want any input delay, and just do all prediction. But if you're simulating everything, you're doing a sports game, you might say, well, why don't we do up to 3 frames of input delay to cover the first 50 milliseconds of latency? Then I'll allow up to another, let's say like 6 frames. This is assuming 60 hertz, but you can configure that. But then you'll do maybe like another 6 frames to cover another 100 milliseconds, and we'll do prediction for that. And then beyond that, do more input delay, right? So that good. Allows you to kind of get the best of all worlds, where you say, well, okay,
that's a good spectrum, because sometimes you just can't help that person. That person, just due to distance or region or whatever, they may get 100 milliseconds plus. But in reality, I would say, like, if someone's above 150, it's kind of like, I don't know if there's much I can do for you, dude.
Yeah,
so
at that point,
I get the input delay.
At that point, we believe like it's better for you to actually feel the latency and have the game still look okay than it is to do what happens in most rollback solutions, where you just predict that far out and everything's a teleporting mess. Yeah,
totally. So really what you're doing is you're saying, and it's sort of the same argument as that first 50 milliseconds, which is effectively, sometimes it's more important to have consistency rather than the perceived minimal latency, but at a lot of, I don't know, I call it the window of bullshit, right? It's like,
exactly.
Like something weird's going to happen.
If that window is large enough, right? How much is being able to respond instantly to nothing because you can't see anything? How much is that helping you? That input responsiveness, right?
So this opens up a really interesting discussion now. Let's talk about a classic first-person shooter paradox. Somewhere in the window of bullshit, this is something that every first-person shooter player will have experienced. I ducked behind cover, I ducked behind a wall, and the guy shot me anyway, but I was already in cover. What happened, Jay?
So typically, what happens is, so we as network guys, right? We can't make latency not exist, right? So there's going to be latency somewhere. And most of this is is us simulating a shared reality, right? And so at some point, you made a decision to go into cover, and so you started pressing the key or the stick to go right, to duck behind cover, let's say, right? That takes some amount of time for you to get under cover, depending on how fast you're moving, things like that. Meanwhile, you are showing the result of you moving to the right behind cover immediately, because you don't want any input delay. That would feel bad.
So
right?
this is
the server hasn't received,
so-called client-side prediction is what we're talking about here.
Correct. And so you've got client-side prediction where I'm sending to the server, hey, I'm going right. And you start going right away on the client. You start going right. So who knows how long it takes for the server to hear that? Maybe it takes a full second. You don't know what your ping is, right? So you're moving to the right. The server's going to get that at some point. Meanwhile, that same exact thing is happening on the other side of the scenario, where you've got a guy who sees you before you've moved to the right. He's aiming and he's shooting you, right? And so he's saying to the server, hey, I'm shooting this guy that I'm looking at right now. This is both happening at the same time, right? So the question is, someone is going to have a bad experience here, right? Either the guy who's aiming you,
defender,
is either wrong because he doesn't know that you ducked yet, or the guy who's ducking is wrong because he doesn't know he's been shot yet. So someone's got to make that call, right?
And here's the thing, that the choice of what's done here is the very flavor of your shooter. Right? A lot of different choices here, but I would say Call of Duty generally favors the shooter.
Most shooters, I think, do today.
Just imagine, I mean, you get a clean headshot off and you're like, I shot the guy. What the fuck? Right? Like scope, sights, shot the guy. I don't get it. Bullshit. Right? Is when there's two people on both, one person on each side. It has to appear consistent, and you have to kind of pick whose consistency wins out.
And I argue that it makes sense for the reason that which side of is the skill really on, right? Like, it's more likely that someone is using their skill to intentionally aim exactly where you are, even if you're moving quickly, even if you're doing whatever, and getting you, then it is likely that you're like using your expert moves to dodge his aim.
Hey, maybe if you have a dodgeball game with a projectile that isn't instant hit, a reasonable argument could be made that like you get some sort of a save chance, and then it becomes an interesting interplay between two different. Okay.
Exactly. So and that's really where design meets networking, that I think is really interesting, right? And this is why with any given network model, right, you can't have it all, right? So you have to decide which box you're going to put your designers in, and they have to play by those rules, right? And
so there's an interesting thing here when you look at Call of Duty. One of the defining aspects of Call of Duty is the kill replay.
Yes.
And why is it there? It's there for this very reason. Because what are you showing in the kill replay versus the perception of the player who was just shot? How is it different?
And this is actually fascinating, right? Because you have, so if you were to send what the server had during this same span of time, right? What you would see in your kill cam is the guy not aiming at the player, right? You would see the guy missing. If you were to sort of naively just send over what the server had at each of these timestamps, right?
And this is because, and I'm sorry we jumped over it, it's because you're doing lag compensation,
right,
on the attacker's shots, so they don't have to lead the target.
That's right. And so you as a shooter are looking at a guy who, generally speaking, you're interpolating, right? So he's in the past relative to stuff you've received from the server. You, as we've just explained, are ahead in time. So you are showing things that the server has not yet confirmed because you've sent it and you're assuming that it happens. And so the server then has to, when it eventually hears that you took a shot, it needs to go back and look at where the guy you were shooting was on your screen when you did that, right? And decide whether or not to confirm the hit based on that, right? And so for that reason, that guy is no longer actually aiming where that guy is. He was aiming where that guy was, and the server simply compensating for it. So if you were to send that naively over in a kill cam, that would look wrong, and you would go, this game's broken, right? And so instead, you actually have to make sure that you are sending the data from that guy's point of view in time, but then sending where everyone was when he was actually doing those things.
So you're effectively reconstructing the client's point of view, his time stream.
What he saw on his screen when he made the kill, not necessarily what was actually happening.
So when we say actually happening, we definitely would agree that it's the server's perception is the actual happeningness.
Yes.
But here we're stretching it a little bit to basically say, you're the shooter. You are shooting at something in the past because we're not extrapolating it for you.
Correct.
Right?
And so in that example you gave of the guy ducking behind cover, you in the kill cam would see yourself get shot, not having yet gone behind cover, because that is what the shooter saw. Right. And this is actually a very challenging feature to implement generically. It's something that Snapnet does lag compensated instant replays and full match replays, so that as you cycle around between who you're spectating, it gets adjusted.
Oh my God, you did that too? I did that code for Titanfall 2. I redid the. It is the hardest. Is the logically hardest piece of code I've ever written in my entire career. I rewrote.
These things are very difficult to reason about.
I made it so that you could delta from the point of view of one person. You could delta a frame to the point of view of another person, and the delta would work. And it did all of the tricks with the make sure that the weapon and the whatever is, you know, all the stuff you got to do.
I do.
This shit's crazy.
It's crazy, right? And so we did that as well. And it's challenging, especially when you're kind of pulling this stuff out of replay file, right? Because you got to pull it out of multiple places because you got to go and get for the different time stream, right? And you're jumping.
Oh, okay. You guys, you drove your implementation from a replay file. Okay, cool.
Well, not the instant replay, not the kill cams. Just I'm talking about a full match replay. The instant replays, I know, for example, like Overwatch in their talk, they talked about how they essentially take a little replay file and then send that over. But we kind of go a more Quake based.
I did it the hard way too.
Where you just change what you're sending, the snapshots that you're sending.
That's what I did.
Client. But that's great because it's instant, you know. But there's challenges obviously to that, as well as, you know, if any kind of future information you need to get and about how to, show a sexy camera angle or something, right? Like that can get tricky. There's stuff in there, but
Cool.
yeah.
So let's talk about another very common thing, a shotgun.
Yep.
Okay, so a shotgun has spread, and that spread is real. But how do we guarantee that the shotgun spread is the same on the client and on the server when the server does the actual damaging? So the real shotgun blast that actually damages somebody is obviously on the server. But if I see spread and I see little flecks of shrapnel hitting somebody, I'm going to feel pretty unhappy if that doesn't actually register as a kill.
Yeah, exactly.
So let's go through this. How do we do it?
Think about the case where you do nothing, right? Think about the case where you just say, look, I'm gonna take the direction you're shooting. Let's say you have whatever logic to generate a bunch of random angle offsets from
roll
there.
the random number.
That's gonna, and then I'm gonna put the things there, right? So what's gonna happen is the server is gonna do its own random numbers, and they're gonna choose certain random numbers, and it's gonna go in a certain spread pattern. Maybe you hit the guy that's in front of you in 3 out of 10 of those shots, right? But maybe the client just showed him getting like a full blast of 10, like 7 out of 10 or whatever. That's not going to make sense then when the guy either does or doesn't die. And it's not going to make sense if you see a bullet impact that is literally right behind the guy and you're like, but that doesn't make sense, it went through him. So you need those things to line up, especially certainly as you get further away and that cone becomes wider. It's even more important because it's the difference between a hit at all and a miss. This is a good example of where determinism matters, but it doesn't have to be strict bitwise determinism as in, inputs, right? So you don't have to worry so much about like, is it correctly rounded to the tiniest epsilon?
Is it bit identical as in like I could step it forward, take a checksum, and the checksum would be binary identical on 2 different machines.
Exactly.
Not at that level. Near enough.
So this is where near enough is important, right? You want to generate the same random numbers, so the spread is the same, even if it's not bitwise identical. So essentially, what you really want to do is seed you can either you could use, there are a lot of different options. I mean, you could use a hash function that has a good distribution and use a constant seed. You could send a seed along with your input if you want to do that. I would argue the easiest and best thing to do is generally use a seed. I generally combine, actually I kind of use like a macro that kind of combines the current line number of the file along with like the some identifier for the object itself, and generate a unique seed from that using the frame, the time, and the so that basically it's unique for the time and the line, the whatever, and then you use that to seed. That.
And it still has differences from one shot to the next. It's just that it's only varying on something that it's really only varying on time and the object number, which is the same on the client and the server. That's a good approach. I've also seen it done where the player's actual input structure for that frame driving that shot is fed into a hash that drives the seed. And but anything that gets the same seed on the client and the server for that spread is the solution. And if you think about it, you can do it without actually sending the seed at all. Pretty cool.
Absolutely.
Okay. So
and it's worth pointing out, right, in a fully deterministic game, right, you would typically start with the same seed out the gate, but because you're always generating the same random numbers in the same order for each frame, that would all be consistent, right? That's not the case in a model like this. So you need for the place where you're generating the random stream to start with the seed relevant to that specific piece.
So effectively, you have a function that's going to go, calculate spread, and it works out all of the bullet rays, and you just stick in a seed that is like, I'm going to hash X, Y, and Z, and X, Y, and Z are going to be the same on the client at the time when it shoots, and same on the server when it runs that player command, and you get the same spread.
Yes.
However you choose to do it.
And one actually very important caveat for any of you trying this at home, there are a number of functions that you'll have, right, for using a random number generator that takes a seed. And you want to be careful, actually, because not all random number generators that take a seed will actually generate a uniform random distribution for between seeds, right? So if you
So
put in a random
wildly
seed and
different.
generate a random
Yeah.
number, you won't get a uniform distribution out of all of that. So if you may find that, because if you're using something like that, maybe your shotgun is constantly skewing to the right more than it does left, or it,
That's quite interesting, and that would be quite an issue, obviously,
yes,
for
yes,
a game based on the uniform distribution of
yes,
shotgun.
or maybe like too predictable, or even if it's not constant, it's
sounds,
like, if it
sounds like a
enough,
lesson
it could be
sounds like
exploitable.
something that might have been learned the hard way, I would say,
Yes,
through
yes,
debugging a thing.
yes, yes.
So,
And so
wisdom.
there are better versions of that. A hash is also a great option, because that's kind of the point of it. Yeah.
Pretty cool. Okay.
Yes.
So we briefly touched on the time streams. So we have the, effectively with the combination of client-side prediction, putting your client sort of ahead of the server. Let's say you're ahead by 100 milliseconds. That's a predicted time stream for that player. Yes. There's also on the server, at least the way that I've looked at it, that I always view it as sort of like, there's a sort of a server time stream that is like AI and objects and everything that just kind of step forward.
Yes.
But each player kind of have their own time stream, and they may move forward only when they get inputs. And this is something not many people are aware of.
Yes.
So every player has their unique time stream, both on their client, but also on the server. If an input does not come in, the server does not advance that player forward.
Right.
There we go.
Right. So this is the way that Quake works, for example.
Yeah.
And so what you'll see is that part of your input command that you send to the server is that it actually contains either a timestamp or a delta time from the last timestamp. It can be helpful to kind of send the full timestamp, which you kind of need to do anyway for some of the backwards reconciliation stuff, but to prevent some of these like speed hacks, right, where you're sending commands with inflated delta times and things like that.
So effectively, every input being sent from the client to the server is not just an input, and the server doesn't just keep extrapolating, holding the same input if it doesn't receive another one. It's actually a series of delta times with inputs at the beginning of each frame. Yes. And this is the Quake way.
Yes. Now, there are some significant problems with that. One being that players then resulting movement on everybody's screen is kind of as bursty as their connection delivery is, which, especially when you
can do a play out delay on that. There are things that you can do.
All these things are mitigatable.
All of them cost latency. Yeah.
Yes. And so there are things like that. There are things like that makes it make lag switches and things like that, where you temporarily block your outgoing packets and then send it all in a burst at the end.
Makes it hard to shoot at you.
More doable. Right. And you kind of can teleport, and all these things can be mitigated. Like, you can have some max delta before you just advance them. You can do, there are a lot of things you can do.
One thing I did, basically, especially with our time stream stuff, when you're doing that lag compensation as well, when you're shooting in the past, common mistake people make when they shoot, they don't clamp how far back in the past you can go. I think even the Overwatch guys were like, they're like, oh my, actually, we brought that down to 200 milliseconds. Because if you're shooting at someone a second and go, you do have a bit of an advantage over them.
Yeah, I mean, it's going to feel more than unfair. It's going to feel straight up broken, right? It's like, dude, I wasn't anywhere near that guy.
Yeah.
So,
and that's where lag switches can sometimes be unfairly, unreasonably effective if you can. Oh shoot! Back to the player hosted service thing. Imagine being the server host using a lag switch. Everyone starts moving. You pop them. That's enough to go to a dedicated server. Right there.
That's it. That's the you don't need to hear any more than that to know.
Done.
Player hosted.
Okay.
It's not worth.
So let's now dive in. We've got snapnet.dev. What's a snapshot?
Well, sorry, one more thing on that last point, because I think that it's with respect to SnapNet, right? Because we want to support fighting games, sports games, things like that. We specifically do not do that. So we have a fixed frame. We do a fixed tick. And so we are not doing the variable delta. Now,
because
one of the advantages though that's great about the variable delta is, especially with people with high frame rate monitors, you got things like you can support that really natively and directly, and so it lets you shave off some latency, right?
I do remember Titanfall 1. I believe, my memory's fuzzy, but I believe that we had to restrict it to 144 hertz, and people screamed blue murder, simply because the server simulation cost of that player at a higher delta was just too much for the server.
That makes total sense.
Yeah.
That makes total sense. I was
so
wondering
there
about
actually
that,
there's a good argument for fixed delta times from clients, because it is a fixed load rather than one person's running at 1,000 FPS and the other guy's running at 60.
Yeah, and the big challenge then, of course, is if you run at a fixed tick rate, then how do you support these variable refresh rate monitors, right? And but thankfully, right, like
you got to decouple the client view and simulation frame rates.
Exactly. So that those have to be separate, and you need, the same interpolation functionality that you're using to interpolate things in the past can also be repurposed to interpolate.
It's literally the same thing
for rendering. Yeah. So
some people might remember the fixture time step article that I wrote in 2001. 20 years later, I can tell you that effectively, that's just the Quake network model.
Yeah.
And the simulation as the server and the renderer as the client in one process. It's basically the same thing.
Yeah. It's awesome.
Cool. All right. So snapshots.
So
why shouldn't I just send down like the 100 most important objects in my packet and have a steady bit rate? Why do I want to have this varying kind of like delta encoding? Because of course the world state is very big, and I'm sending only the differences from the last state the client got and the next one.
Yeah.
Why do I want to do this complicated delta and snapshot thing? What's the advantage?
Number of advantages. One, at a just a pure implementation level, right? If you consider doing partial state where you send like the most recent 100 or whatever, it can become even more challenging then to send a delta. And one of the advantages of sending a delta is that you're really making efficient use of bandwidth, right? You can really get things quite small when you're doing good delta encoding. You can kind of noodle that forever, so there's a danger, and like you could spend your whole life shaving some bits off, but even the coarse version, you're getting drastic savings in bandwidth, right? And so the reality is
order of magnitude reductions.
And so the reality is that the more you can fit, right, the more data you're getting over, the better the experience for the end user is. So there's that.
And also let's face it as well, the world is not going to a low bandwidth future, right? We'll have a gigabit, 10 gigabits within 10 years for everybody. And what are we going to put in there? Well, it's not going to be necessarily a deterministic input based synchronization. It's going to be a big honking snapshot. Right? Snapshots are going to win. Because when bandwidth is no longer as scarce as it was, and we're already living in that world, megabit or 2 megabits can be sent down. You can represent with a delta most of the world state of a very large world in that at some rate like 10 hertz or 20 hertz or 30 hertz.
I mean, you can even do pretty large games at 60, and it's with modern bandwidth stuff that's tractable, and it's only going to get easier, right? And one of the other massive benefits though, right, is as I was saying earlier about the fact that games are about these objects interacting, right? I mean, if you say, oh well,
you can't take an object in isolation. It's about multiple
like I do something and that affects this guy's state, and I touch him and now he's infected and I'm not infected anymore. Whatever it is you're trying to sync, right? Are you going to now have both two people that look infected? Neither, right? Depending on what order you get these
one
updates,
or the other.
Or you can, are you going to, when you drop a capture the flag, is the flag on nobody for a time or just on one guy? Do you see two of them, right? These are things you got to deal with that like you want hard guarantees about, right?
Another good example is like myself and my Titan and my weapon and my inventory and that cloak that I'm wearing and all the stuff. They're all objects. They're all really, I think of it this way, you're going to have to either know every object dependency or interrelation. And then you're going to end up pulling most objects in anyway. You can't just kind of go this object only.
The big danger of course is like, look, as a there's a big difference between whether or not something's technically possible and what it takes to get you there, right? Can you do partial state and get that correct? Sure, right? Ish. But the reality
is it always
like,
going to be correct? Can it be guaranteed?
But like,
correct?
How do you know that in all scenarios of how long these things can be delayed or other things that have been going on that can starve out this thing from getting in the packet, right? That you're not going to have a massive bug that
Yep.
you haven't tested, right? Like there's
Yeah.
no way for you to validate that. It's impossible.
It's intractable to validate. I mean,
Yeah.
I remember when I was working on God of War Ascension.
Yeah.
Everyone was like, you got to do Late Join. You got to do. I'm like, I can't do it because the world state, like, I can't test.
How do you know when you've gotten it all?
Yeah. How do I know when it all works? Because it'll look like it works, and then there'll be a billion edge cases, and then someone will join in between X and Y, and it will be, the world will be broken for them for the rest of the game.
Yeah.
And I was just like, we can't do Late Join. Just, it's a technical decision that was made years ago. I know we want it. I know it's unfortunate that we can't do it. I know we need it. But the network architecture that was done, which was a peer-to-peer with one person acting as the server for level logic, I can't Late Join in that and then get an initial snapshot of that entity system. When I say entity system, I just mean in the God of War engine, the entity. It was kind of like the level objects and like the states of various invisible objects and triggers and stuff, like complicated stuff that you don't want to have wrong.
Yeah.
Right?
Like
I couldn't guarantee it.
Breaking stuff that really should only has to go forward in time and always be consistent, right? Like,
There's a big difference between looks like it works and like I can prove and know that it works, and I know that it's generally going to be problem free.
Yeah,
and massive delta.
And then there's two more issues, frankly, which is one is, I'm sorry, but when you've got knobs on how important something's supposed to be and you're trying to noodle that based on like screen size and camera frost, like you're never going to get that. What is the right answer, right? That is like you're giving a billion knobs to someone and you're pretending like there is some tuning of those knobs which is correct.
So here's the typical.
That's not the case.
Here's the typical Unreal way. And I've done this in the past too, and I found that it works very good for physics simulations, but I would never use it for game code. For a simulated system for where an extrapolation is high quality, I would contend that it can be an effective bandwidth optimization, but even that's not going to be the case when bandwidth is effectively infinite within the next 10 years, right? For any reasonably sized scene. But the bottom line is, look, you were sitting here with enough bandwidth to use. Your choice is basically, do I have an eventually consistent system, or do I just show the visual results from the server in a series of time tagged snapshots, each one a specific vertical column of all world state of all objects at that time, and then I know that it's always right.
And you can view any of those and it's consistent and that it makes sense to the player, right? And furthermore, right, the other issue is, let's say that you only want to show known good states, right? And you're sending partial states. So the problem is you're either then going to be showing different objects at different points in time because you have to interpolate them based on that, which has its own consistency problems, right? Which we just talked about. Or you can only interpolate based on the one you've heard about least recently. In which case, why wouldn't you just send it all?
Yeah, and then the server has to kind of
be more recent.
How are you then going to on the server reconcile with that to work out in their time stream and then in that? It really is sort of, I would just say, look, at the end of my career, Unreal partial state style networking is approximate and sloppy on the point of view of the client shooting at trash.
That's right.
Really shooting it like what?
I think it can be quite useful for games that are large and non-competitive in nature. Right. Yeah. So like if you could just let the client games, be authoritative over a lot of stuff, like, I shot that enemy monster, that AI monster. Who cares if you lied? Okay, fine. And you're showing things, and as long as it is approximately correct, you don't care. But if competition, if competitive integrity, if any of that is important, it's near impossible, I think.
You should be shooting at a defined interpolation between two known snapshots, and then the server will wind back in time, do the exact same interpolation, reconstruct the position down to the freaking bone level, shoot someone on the kneecap. The knee will be in the same place on the server when it reconstructs the point of view of the world as per when that person shot in the past. And that's the bar for this top tier stuff.
Right. And then the benefit is when you do that, you can just write your game on top and you're not figuring out like, well, where am I going to hide the latency for this grenade toss? Right.
There's another thing as well that I really like, which is when you do a snapshot based approach, for the vast majority of objects which are not owned or controlled by the local client, you can get away with sending only visibly relevant state. Now, assuming that you're not simulating between snapshots like in a sports game, but you could be sending enough to drive the animation, the position, and the orientation, but you don't even need to send velocity if you're doing a lerp.
Yes,
right.
It's
you don't need to send
important.
the internal of an engine for a car.
Correct.
Right. So
it's super important efficiency wise, especially when you start doing larger games, that you can send data for the stuff that you're interpolating at a totally different precision. Some things not at all, some things differently, completely.
That's totally true.
Do I need to know how much ammo that guy has? Why?
You don't. Yeah. Unless there's some sort of visual. Yeah. I need to know my own because I'm predicting and running So there's a concept that I call deep versus shallow synchronization. So a deep synchronization would literally be like myself and all of the internal, my inventory, all the bullets in each thing, everything I have, the cooldowns on every weapon, my health, everything. No one else can see that, right? But I'm predicting, rolling that back, simming it forward in response to input, and it has to eval the same steps on the client and the server, otherwise everything goes to hell, right? Deep synchronization.
And
shallow is just me. I'm here. I have a position. I have an orientation. Here's my animation state, and anything else that's potentially visible, but only if the visibility of it is relevant to other players.
Yeah, to just purely visualization, and even furthermore, right? Even within just that limited set of data, like position orientation, you need that at a far lower precision, right? Than if you're simulating,
because you're not going to extrapolate,
right? And because you're not going to have to depenetrate, right? If you're slightly off, that could put you on the other side of a wall technically, and you might need to push out. But if you're just interpolating where the guy is, like that's close enough.
Yeah, it's good. Yeah, it makes perfect sense because when you're running simulation on it, you could be fighting the simulation with the quantization. So what often is done, and I've done this in the past, is you actually have to quantize on both sides to make sure that the depenetration doesn't kind of mess you around when you force the sync, right?
Yes.
But if you're just showing visual state and interpolating it, there's no simulation running behind it. And in a game like Call of Duty, Titanfall, Apex Legends, and Counter-Strike, every other object that's not you is just an interpolation.
Yep.
And that's the way it's done.
Yeah.
Cool.
Yeah.
Wow, we've covered a lot of stuff today.
Yes.
Thank you so much, Jay. So let's just wrap it up now because we could talk forever, but I just want to final props, snapnet.dev. Is it an open source project or it's a commercial project?
It's not. It's a commercial project.
It's a commercial project. So if you're making a game and you're wondering, how do I get my hands on the best of breed Quake Netcode, snapnet.dev, reach out to Jay. Jay, do you have an email people can contact you on?
You could just email me at Jay at highhorseentertainment.com.
Brilliant. Jay, thanks heaps for being on the show. Awesome chat today.
Yeah, super fun.
All right, man. See you around. Bye-bye.
Bye.
Cheers.
Here's the hard truth. The internet doesn't care about your game. After all the blood, sweat and tears you put into making your game, you launch, and some players get terrible network performance. What can you do about it? Build your own internet? This is why we created Network Next. Network Next is a radically new way of linking networks together. It's a new internet. One where networks compete on a neutral marketplace to carry your game's traffic. Network Next puts you, the game developer, in control of the network. We monitor every player's network performance and you choose when to accelerate them. Not only will you see better network performance for your players, you'll also have the security of knowing that if one network is congested, we switch to another in seconds. Now you control the network.